So doing linear regression review, just the first part of lesson 34. We'll finish it tomorrow. I want to begin by reminding you of things that at this school we require you to show on your linear regression problems. First thing that you have to do is to have the calculator figure out the equation of best fit. So you have a bunch of data points, they give it to you in a table, and you're going to enter all of those on the calculator and have the calculator figure out what would be the straight line going through the scatter plot that's the closest possible to all of the points. You are also going to analyze that line. So to analyze it, you are going to write down what the calculator says R equals. That is called your correlation coefficient. And you are going to say whether that is a good model or not. The sentence frame that we use for that is there is a weak, moderate, or strong, either positive or negative, linear correlation. Don't forget the word linear. We're not doing quadratic regressions here. Between the independent and dependent variables. And I expect you to write those out, no abbreviations. So if it's carbon, you're going to write out carbon. You're not going to just write C. So if it is a positive R, that's going to mean you have a positive slope. That's the positive linear correlation. If R and M are negatives, that's when you have a negative linear correlation. We will talk on the next slide about how we decide if it's weak, moderate, or strong. Strong will mean almost all of the points are right on the line or very, very, very close to it. No correlation, they're just kind of all over the place. The final thing that we are going to do is to interpret it, which means we are going to explain what the slope means in the context of the problem. So remembering that slope is rise over run. It is the change in y over the change in x. Except when you do these with the calculator linear regression, it's going to say m equals some decimal. It's not going to give you a fraction. So we are going to make that into a fraction. It's not the kind of fraction we'd normally take as some kind of a final answer, but for the purpose of figuring out this sentence, it works just fine. We are going to say that the slope is that decimal over 1. Now, normally we would not leave a decimal inside of a fraction, but for the sake of interpreting this, we're thinking of the decimal as the change in y, the 1 is the change in x. So I'll put up a couple of sentence frames that you might choose between. For every 1 gram increase, for every 1 pound increase, whatever it might be, and this one will always be increase. For the first one, it's only increase. So that is the independent variable, that's the x. For every 1 that the x changes, that's the denominator of slope, that's the change in x. That's why I'm using the 1 right there, decimal over 1. Our model predicts an average, either increase or decrease, depending on positive or negative slope, positive or negative R, of, and then you're going to name the change in y. So the change in x was 1, the change in y is whatever that decimal is, which is the slope. Fill in the units, and then in whatever the dependent variable was, potassium or something like that. I'll let you get away with abbreviating your units in these sentences. You can do G for grams or kg for kilograms, but not for the variables. I want the variables written out. So that is one sentence frame that is a really good one to do. The average means we're going to have our line of best fit, and the points aren't necessarily exactly on that, so our prediction isn't going to be 100%. It's going to be close to it. So on average, that's what our increase will be. When I did the keys, I was not using the predicts an average, so the keys may be more like this. First phrase is totally equivalent. For every 1 unit increase in the independent variable means the same thing as when that independent variable increases by 1 unit. So I don't care which first clause you use on that. The model predicts that. On average, the model predicts that the dependent variable increases or decreases by whatever the slope would be with the units. So pick whichever sentence frame you like, and you plug in for everything that is either in parentheses or underlined when you are actually filling in that sentence frame. So does that make sense of how to use? Should be similar enough to what you did last year, regardless of which of the 3 teachers you had last year. So that brings us to the point where we need to go back to that step number 2 with the R value. Is it a weak, moderate, or strong correlation, and how do we decide? Does anybody remember the biggest R value and the smallest R value that it's possible to get? 1 and -1. So the biggest we could have is 1. The smallest is -1. If you ever get R equals 1 or -1, that means you have a perfect fit. That means every single data point is exactly on that line, not just close to it. I mean, this is 0. If you have positive, that means that you had a positive slope or positive correlation. And if you have a negative number, it means that you had a negative slope and a negative correlation. Now, I don't know about you, but if I'm pretty close to 1, I'm going to say that's a strong correlation. I'm pretty close to -1, same thing. If I'm at 0, I'm going to say there's no correlation. My dots are just all over the place. And I don't know whether my line goes like that or that or that or where it goes. Impossible to figure out. If I'm close to 0, I'm going to call that a weak correlation. That means the points barely look like they're increasing or decreasing, but they're still scattered quite a bit all over. And if I'm somewhere in between, I'm going to call that a moderate correlation. Or sometimes if it's really, really weak, I might say there's barely a positive correlation or something like that. You can use some synonyms on that. Now, some of the books, and last year we talked in some of the classes about, well, if it's 0.9 or better, we're going to call that strong. Or maybe 0.85 or better. Or sometimes the books say, yeah, but if you're talking about people and the way people behave, it's hard to predict that, and you're never going to get something that's real accurate. So if it's 0.6, we'll say it's a good model. So it's a judgment call. So I'm going to let you use your judgment, depending on the context, what kinds of things you might be using it to predict. You know, if it's a life or death situation, I'm going to want it pretty doggone close to 1 and -1. If it doesn't really have high stakes, I might not care so much. That's how it really works in statistics. It is a judgment call depending on how it's going to be used. Now, if you say that your R value is 0.1 and you say that's a strong positive correlation, I'm probably going to argue with you on that. Does that make sense of how we're going to do that? Okay, let's do one example together then. And so we are going to enter this in the calculator. The book, and I want you guys to ignore the answers in the back of the book on the odd ones, because they are not doing it with the calculator yet. They are giving the graph and expecting you to say, oh, these 2 points look like they are the closest to being on the line. Figure out which ones they are. Do y2 minus y1 over x2 minus x1 and figure out the equation that way. We're not going to mess with that, so our answers will be different from the book answers. From the graph that they gave you, strong, moderate, weak, positive, or negative linear correlation, what do you think? Probably a strong, positive, or negative? Positive. So I gave you guys a handout of what we're going to do. I have the data written over here on the board on the side as well, so that we can attempt to enter this. So from your home screen, do not do these on a scratch pad. You need to create a new document, so that is choice number 1, and follow along on the sheets that I gave you for the steps. First thing we need to do is to enter the data, so that goes in a spreadsheet. So option 4, you have to use your arrows and go up to the box that says A and enter the name of your X variable. So I'm going to call that anteaters, so ANTEATERS, and then I'm going to go with my down arrow to box 1 and start entering those numbers. So 34, enter. 49, enter. 63, enter. 77, enter. 91, enter. 106, enter. 120, enter again. Then I need to go back up to box B using my arrows. And I need to put in the name of the other variable. So CARPENTERS. Can't have a space in there. It does not like spaces. And then I'm going to enter that data, 810, 990, 1180, 1060, 1250, 1430, and 1320. Now, when you go to the next page and start doing things, if you get an error message, go back to this page, and you probably left it like I did. I did not hit enter after that last value. Do you see how 1320 is on the left side of the box and not on the right like all of the others? The calculator thinks I haven't finished entering it, so it's not registering it yet. So it thinks I have one more entry in the first column than in the second column. So keep that in mind as one of the first things to check if you get an error message. You just go back and you hit enter. So now I have all of my data in there. Now, depending on what we want to do next, if we don't need to draw the scatter plot, we can simply do a calculator page next. So we are going to go back to control and then the dock button because it says plus page above it, so that means add a page. And this time if I do a calculator page, that is choice 1. So I want to analyze what I've entered. Ronald? They're up here on this board right here. So on this page then, we're on the calculator page now. Menu is my best friend button. And I want to do statistics, so choice 6. And I want to do some stat calculations. I want the calculator to figure out what R is and everything. So choice number 1. And then I want to do a linear regression, but this has 2 kinds of linear regressions. I don't really want an equation that is y equals a plus bx. I don't know if they do that way in some other country or what, but we do y equals mx plus b, so I'm going to select choice 3. And then I have to tell it what my data is. So for my X list, I get the drop-down menu. I chose anteaters for my X's. My Y list was my carpenter ants. And then I want you to pay attention to the next line. Save it as F1. Depending on how you do this, if you just create a new page for the next problem and do that data, your next one will be F2. If you realize you made a mistake in it and you redo one of them, your settings weren't right or something, then it'll go up to F3 for the next one. So pay attention to what that is. So if yours is something different from F1, remember it. Help me remember that mine is F1. We'll need that later. Then go down to OK. And we have everything we need about our equation. So I can write down that M is 6.214. X plus B is 669.215. R, not R squared, is 0.908. Does that fit with your prediction? That's a pretty strong correlation. Okay, so then once we have that information, let me go back to my screen with the problems so that we can write down what we have. Now, I didn't write y equals because they told me in the direction on the problem right up here that they wanted me to use C and A for the variables. So I'm going to do C is 6.214A plus 669.215. R is 0.908. Filling in one of our sentence frames, there is a strong positive linear correlation between the number of anteaters and the number of carpenter ants. Everybody good with that? We could also predict, or we could also interpret the slope in that context. So as the number of anteaters increases by 1 for every 1 increase in the number of anteaters, our model predicts an average increase because why? What was positive? Slope was positive, and that increase will be, whatever the slope is, 6.214 carpenter ants. Does that much make sense? Okay, depending on the problem, some of the problems will ask you to actually do a scatter plot. So if you need the scatter plot with a line on it, we need to add a page, so Control plus page again. This time it is data and statistics, choice 5, but we need to tell it what the variables are. So we go down to that box at the bottom and click on it so that it shows our choice of variables. My X's were anteaters, and I do the same thing with my Y-axis. My Y's for this problem were the carpenter ants, and there I have a scatter plot like we saw in the book problem, but no line on it. If I want to add the line, what's my best friend button? Menu. And so this time I'm wanting to analyze the graph, so choice 4. I want to do a linear regression on it. And that isn't what I meant to do, so I clicked the button too fast. What I wanted to do was menu, analyze graph, 6 for regression. I guess it was the right one. It was already highlighted, wasn't it? So then 1. So there's the 6.214x plus 669.215. And, oh yeah, I did a quadratic or something on there. That's why that other one was curved. But the straight one is the line that we're talking about. Does that make sense? Okay, one other thing that we might want to do on some of these problems. What if you had one that said, how many ants would you expect if there were 50 anteaters? So if X is 50, what do you expect for Y? We will not put a 50 in here times 6.214 plus 669.215 because these are rounded numbers. And we never reuse rounded numbers. So what we have to do instead is go back to our calculator page or add a new calculator page in our document. So I've got the little blinking cursor. It wants me to do an action. I am going to simply push the variables button, and let's see, I forget. What was my F? Where did it store it? What was mine? F1, whatever yours was. Find it in your list. So find F1, and it types F1 with the parentheses for me. All I have to do then is put 50 inside of that parentheses, enter, and it's going to tell me that I had 979.909. So I write that down as my answer on this part, 979.909 carpenter ants. But does it make sense to talk about a fraction of an ant? So we'd probably say 980, and I would like to have both, the one from the calculator and then how you rounded that. Any questions with that?